Okay, so if you're not familiar with it, the Ruby Rogues is a new podcast I've been working on with a bunch of other guys, including Obie over here to my left. He's another regular. And each week we get together and discuss some topic relevant to Ruby. Sometimes it's a hot topic in our community. Sometimes it's just something we care about. Sometimes it's a random idea we get off of Twitter. You never know. But we tend to discuss it for a while and give our opinions on it, and it's a panel discussion, so we usually uncover some interesting ideas, I hope. This is our first ever live show, so we'll do that here, which is cool. We have guests, which is normal for us. We often have guests on the show for various reasons. We're missing some of our normal panelists, obviously, because they couldn't be at Lone Star, so we missed them, and that's why I'm hosting, which I don't usually do. But we're here, we're going to get started. This time we're going to talk about science and engineering in our field, computer science, basically, and kind of some of our opinions on that to kind of tie in with Glenn and I's talks this morning is what led to that. We'll do this a little differently this time. I'll let us talk for a bit, and then we'll open it up to questions, and we'll answer anything you guys want to ask us. So that's our plan. So I'm James Gray, and I'll be the host today of Ruby Rogues. I've been in the Ruby community a long time and worked with a lot of projects in the community and obviously at conferences and stuff like that. So that's me. And I'm going to have the other panelists introduce themselves. So Obie, go ahead.
I am Obie Grimm, and you're not. Anything else you want to know is at ovd.org.
Glenn?
I'm Glenn Vanderburg. I'm a tech lead at Living Social.
And Obie?
I'm the one and only Obie Fernandez, and I wrote the Rails Way and the Rails 3-Way, and have been around this community for a while.
All right, so we've got lots of great backgrounds here, and we should get a pretty varied opinion. I'll try to get us started with a couple of questions, but hopefully the discussion will just kind of take over from there. So this morning I said I would like to see a lot more science in the things we do as computer scientists. I would like to see us, did I go off? Is that,
lost you.
Okay,
There we go.
A lot of science in the things we do and test, the way we test hypotheses and things like that. But I've seen lots of opinions here, right? Even Glenn's talk a little bit talked about what to do when we feel like we can't do that. And then I've seen other talks here today which says actually computers is more of a design discipline. It's not so much a science. And I think we all see differences of opinion like that all the time on what it actually is that we do. So I think it's clear that I think it's at least large part science. I would like to hear what some others think it is. So we'll just go around the table. Obie?
Well, nowadays, I mean, what I'm hammering the most is that it needs to be much more of a science. But maybe not in the way that people associate it, not in terms of like lab coats and things like that. Just science in terms of the scientific method, which means you basically have you identify an assumption, and you based on that assumption, you expect a certain outcome. So what do? You have an experiment which should prove that assumption, to some degree. And we do that to some degree when we test for implementation. So we assume that a particular piece of code is going to make a certain test pass. Although we kind of reverse it if you write the test first. But anyway, and I'm saying, actually, we need to do that for everything. We need to do that for the particular design of the software. We need to do that for features. We need to do that for refactoring of a code base. So refactoring should change the velocity of the team. That should be something that could be lodged into a process system in such a way that if the technical debt increases to the level where the velocity drops, that causes your build to break, quote unquote. Holy crap, the build is broken. We have a red bar. We need to fix the build. How do we fix the build? We refactor the code base to eliminate some technical debt so that we can actually get back to a reasonable velocity. Now the build is not broken anymore. It may seem like I'm conflating terms here that are not usually put together, but that's what I'm saying is they need to be put together. We need to get to a point where non-functional requirements are expressed equally in a test suite as something that can be broken.
So Glenn, I thought your talk kind of said the same thing this morning. Like I'm thinking currently of your spork example and the kind of problems it leads to. You want to add to that?
Well, so science is a word that is often misunderstood, and people have idealized or, in some cases, overly grandiose, or in some cases, not grand enough ideas of what the word science means. I think that we all ought to do science all the time in our jobs. I think that software development should have more science in the small, not necessarily science in the large. By that I mean, when some people think of science in the large, they think of big projects that try to discover universal truths and laws, and there are a lot of people who, at various times in the history of our field, have said that we need to use that kind of approach to figure out how we ought to be building software. And I think that's kind of a losing proposition because there's so much contextual in projects and what we do. And quite frankly, there's our field is kind of a bunch of babes in the woods about how software really ought to be built. But science in the small, being empirical about decision making and measuring the results of those decisions and feeding that back into our process, that kind of science we all ought to be doing more of every day.
So Avdi, you've been kind of the spectator in this exchange this morning. What do you think about science and computer science?
Well, I kind of want to push back on Glenn's point a little bit and say that I think that we are at a very young stage in software, but there are a few things that we do have some data on. And I've seen some people say things lately that are kind of along the lines that we don't know anything about software, and we do know a few things. I mean, one of my favorite books, one of the books I push a lot, is Code Complete by Steve McConnell. And one of the things that's really special about that book is, unlike most other code construction books, it really focuses on, here are some things that people have done research on, here are some things that people have run numbers on very large projects and seen correlations.
Right.
And we don't have that on a lot of things yet, but we have that on a few basic things. Like we have pretty good correlations on the idea that more paths through a particular piece of code, through a particular function, is correlated with more bugs.
Yes.
That's a pretty basic thing, but it's pretty well proven at this point. There's been a lot of data collected on that, and so at kind of that level, I think it's important to recognize that there is some science, there is some prior art here, and some research that you can do, and so when somebody says, well, I see that refactoring and it looks really elegant, but that's just like your opinion, man. That it's actually not just. In some cases, it's not just your opinion, man. In certain cases where it reduces the number of paths through the code or something like that, we know empirically that it's likely to have fewer bugs.
But there can definitely be exceptions to cases, I think, like even just how a compiler will inline methods, where it's great to extract things out, but then it turns out when we actually need the raw speed, the easiest way to get it is just to shove it back in there, right? So I think there can definitely be exceptions and stuff. I thought Glenn's point on science in the small was really great. And Obie talked about this a lot, that everybody thinks science is in a lab, and I've really tried to get this across in my talk this morning, that the example I used was my 1-year-old daughter is doing science every day, right? She's observing the world, she's making hypotheses, she's trying them out, she's getting peer review from me, hopefully, and that's how she's forming her ideas. And actually, I watched Avdi's talk today, which is basically a brain explosion of everything you can possibly think about of exceptions in Ruby. And when I look at that, what I think is Avdi's doing science. He's made all these observations. He's got a lot of hypotheses about how this leads to better code. And he's past the point where he's tried to prove them wrong himself, and his ideas are getting really strong. And now he's putting them out there for peer review with things like his exceptional Ruby book and stuff like that. What do you guys think about that? Do you think that really is science?
I think that's a soft kind of science, but yeah, very much so. It's being empirical about the kinds of decisions we make day to day in software, and thinking them through, developing hypotheses, basing those on your personal experiences, which is kind of a weak, narrow kind of evidence, but then you reach some conclusions, preliminary, and throw them out there and see if other people have the same kinds of experience to back that up.
The blog posts essentially function in the way that journal and white papers would function. I wonder if there's an opportunity for someone to come along and kind of catalog these in the manner of a scientific journal, on a quarterly basis or something. It would be different than whatever is the hottest thing of the moment. It would be taking the approach of what is the most significant work, quote unquote, that's been published in blog format that is scientific, that it shows some empirical research and establishes some conclusions. Maybe that's something for someone to pursue.
Avdi?
I think that's a neat idea. I think it's something that would be needed. I mean, it kind of reminds me of my pick last time, which was the Hacker Monthly, which sort of takes a few really good articles out of Hacker News and puts them together in a nicely formatted way. And I think it would be good to have a journal along those lines, only that's more focused on engineering and computer science.
There are a lot of blog posts that I've read over the years that I keep, referring people to, but if they don't have somebody to point people to them, they're otherwise kind of just lost out there among all the others because they're not the hot new thing anymore.
Well, the main way if you've ever done research on white papers and stuff like that, the main way you discover other white papers is through the citations.
Yeah.
So maybe even take it a step further and say, okay, well, we have semantic markup or other maybe lighter weight types of constructs that we could use to establish formal citations from one blog post to another, or maybe when you actually prepared them for publication in this journal, you would actually list the links to the concepts that were. It'd be a labor of love for someone probably.
Certainly,
it's not going to be a profitable.
Yeah.
So I have kind of a question that just popped into my mind. I think really for both of you, I've been thinking a lot about what I guess is effectively science in the small lately. In just my personal process of developing software, I would like to run experiments. I would like to discover which things make me faster, which things make me more effective, and not just faster, but also write more effective code. And I've kind of run into a block as far as how to go about that. What is a good measure? I can think of dozens of little measures, but I've been trying to think what is one or maybe 1, 2, or 3 good measures of personal productivity, personal process that I can apply to my work and say, yes, this definitely improved me. Really for both of you, I guess starting with Glenn.
I was afraid you were going to say that.
Well, I can
Okay,
take
jump in there, yeah.
Lean software development has the concept of minimizing work in progress, and I think you measure the times that it takes, to go from one stage to another. Mm-hmm. And if you had a system for keeping account in an empirical way, how long it takes for you from the time that you come up with an idea to the time that you specify it in some way to the time that you implement it and are able to make some use or decide that it's garbage and throw it out. And you had a system that actually captured that passively for you, so that information passively. I think what you'd end up with is a repository of data that you could use to determine a score for yourself. So are you improving? Are you getting faster, more effective at minimizing your work in progress, at getting through the stages faster? Because obviously the faster you get to decide whether something's good or not, the better, right?
Right.
That's one way I would go for it, because it has applicability in the small and the large, right? It has applicability for someone personally, and for a whole team, and for a whole company.
So I thought I'd just jump in there real quick. Zed Shah does have an idea that I really like about his metrics tracking. He used to be pretty religious about that. Built a lot of shell scripts and stuff to track when he was adding code, when he was making changes, check his build, how many errors are in it, how many warnings. And then he would turn that into graphs using like R, so he could see, you know, when I was doing this particular thing, I would go this far. And I think that's kind of what Obie's talking about, maybe on a small scale, and that it's just kind of one person.
We were roommates when he was first kind of getting heavy into that stuff, so that might be some of what's bumping around in my brain. But yeah, he was very, very anal retentive about, you know, keeping logs of those things, probably to an extent that none of us would be able to do on a natural basis, and that's why I said passively.
Right.
So if we build it into our tools, into our editor, you know, into our shell, you know, and there's so many out-of-the-box things that you can think of. You know, if you go after that goal of picking up that information, think of almost everything that you do on your computer leaves an artifact of some sort, whether it's system log entries and
The
so on.
timestamp.
Yeah.
So
All
kind
sorts
of
of things.
expanding on that, Zed did one of the peep code screencasts, oh gosh, I can't remember what they're called now, the series where Jeffrey sits down with a developer
Over the
and they
shoulder or
just do something, do some quick experiment, play-by-plays, maybe that's what they're called, play-by-plays. And he did one with Zed, and Zed goes through his metric thing in there, and he's using his version control tool on that one, which in his case is Fossil. But he's using it as a way of tracking his changes and getting his metrics and stuff. So it's like what you're talking about, that information was already available. He just put it to a new use. You know?
Right.
Okay.
You were talking about sort of, you know, getting through feature backlog and things, and I thought of a related kind of inverse metric that I definitely need to start tracking, which is yaks shaved per day. And you know, half joking, half seriously, I really should keep track of how many times I wander off into something that isn't the highest priority right then. And I always have that moment when I realize, okay, I need to go redirect myself back
It's hard
here.
to own up to that sometimes.
Well, yeah, it is.
You think, well, this is related to what I'm doing.
Related to something I was talking about in my talk, you know, fundamentally you asked a question about productivity, and in software, any measure of productivity is hampered by the fact that we can't define what a feature is, and in any measurable kind of way, certainly not so that we can correlate them based on size anyway. And what that means is inherently all these metrics are going to be proxy metrics for what we really want to know. And that leads us into one of the traps of Gilb's law, which is, yeah, this is tremendously useful to do, but you need to be aware that these are second or third order, measuring second or third order effects related to what we really wish we could be measuring, and treat those numbers with the gravity that they deserve, which is perhaps not very much, or be aware that they might lead us towards optimizing things that don't actually optimize the productivity.
Well, this is where using a tool like Hissmetrics has been eye-opening for me, because maybe we're not meant to be measuring features. Maybe that's just wrong.
Sure.
Is that, you know, it's barking up the wrong tree. However, you can measure the time that it took to influence a key metric.
Yeah.
And the key metric, by definition, is something that affects your business.
Mm-hmm.
The reason you're doing it is for business.
Right.
So I think as more people come around to using systems like Hissmetric, you're going to necessarily see a reorientation of the way that we define productivity towards those key metrics, and I think that will be the best thing that's happened to our industry in a long while. But one of the reasons that I'm so bullish in saying that it's a greenfield opportunity for people is that KISS metrics is only one way to do this, right? And it's not free. You know, it's cheap, but it's not free. You know, there could be open source solutions that could be created that basically do very similar kinds of jobs and tie into an infrastructure that is extensible and has plugins and gives us all the goodness that we've come to associate with testing tools, except at this higher, you know, business level. I don't really see a lot of innovation there right now. I mean, you're seeing little stabs at it, right? You're seeing like Vanity for split testing and some of these little libraries being created that kind of start to inch you there. But like, what's the next Rails? Next Rails is you know, when someone comes along and pulls this all together into some sort of scheme that holistically gives you that next big leap in productivity. And
A/B testing definitely is gaining in popularity, I think, as people begin to use it to determine things like that. You know, I've seen more and more people using it. I've seen people posting on Twitter things I wouldn't even think to use A/B testing on. Like Peter Cooper a few days ago posted that he had done some A/B testing on whether or not he gave the number of subscribers to Ruby Weekly on the sign up form, you know, or something. And it turns out it's a big difference if he does or doesn't on how many people actually sign up to Ruby Weekly. So, you know, tracking. It's basically what I think you're saying is that we have to stop trying to track these artificial things like lines of code or things like
coverage,
that. Right, exactly. And start trying to track the metrics that
and
actually
other
matter
kinds
to
of
our
static analysis, you know, metric foo,
Right.
I think it is pretty much worthless as something to track on a regular basis. To use those tools in a focused way to drive a particular refactoring episode, sure, yeah.
Right.
But to use it as a metric that you're going to track as some sort of reflection of the team's productivity or value, no, I don't see it.
So here's a sort of a related question. I'm an independent consultant. How do you track client happiness?
Survey.
Yeah.
Survey, yeah, maybe.
Mercury app, yeah.
Mercury app.
You just got to do it on a regular basis, right? Like an everyday basis or something, so that it's not.
Just poll them.
You just poll them, yeah.
That's an interesting thought. I guess one of the reasons I often think my clients are happy is they send new people to me. You know, somebody else has some project they're working on, and they're like, "Oh, you should go talk to the guy who did this for me because he did what I wanted, and he'll hook you up." So I guess sometimes I view that as a measure of happiness, though it's very, you know, abstract.
I think a lot of these things we're talking about will finally come about when we all have heads-up displays and, you know, off neural net processing agents and things that just kind of know to keep a tick mark as to the fact that somebody gave you a reference and
Right.
you know, be able to pull it up. You know, for now, since we're kind of limited in what we can do, we only have these kinds of approximations and what ifs.
Now, see, that sounds like the next Rails.
Yeah. The heads-up display. Let's get to
Yeah.
work on that. Okay. I want to go to one other thing that I thought was really interesting, kind of an accidental correlation between Glenn and I's talks this morning. I was talking about how in science we always go forward with just whatever our best ideas are currently. And, you know, I use the theory of gravity as an example, which Newton got close, and we use that for a time, and then Einstein refines into general relativity. But Glenn also had a section in his talk about, you know, being able to sit down and do an experiment and figure something out. That's great. But also when I'm at work, some days I just have to solve this problem right now and I don't have time to experiment or think through it or whatever. How do I go forward when I don't have the data that I need or whatever? And I would love to hear everybody's opinions on that. How do we go forward when we don't have the ideal data? Avdi, you want to start us off?
Ooh, that's a good one. Appeal to authority. I'm half serious. I mean,
Yeah.
so So I got to thinking about that particular logical fallacy after listening to James talk, and thinking about how sometimes appeal to authority can be really misplaced, but sometimes there are people out there. I mean, there have been people in my life, in my programming career, that they had solved the exact same problems before, and this was sort of driven home to me recently when I was researching a post I did about the law of Demeter, and I was reading the original Demeter paper, which is a great read, and it's a lot more sort of nuanced than you're thinking of when you think about the law of Demeter if you're familiar with it. And I was just reading through it, and I was thinking, this is from the 80s. These are the exact same problems that we're focusing on now, same size program, same kind of dynamic object-oriented system. And so, we like to think that we're breaking new ground all the time. But the truth be told, that even with such a young industry as we have, there's a ton of prior art out there, and there's somebody out there that has solved a similar problem. And so, I think the place that I first turn to is just to try to find somebody that has solved a similar problem in the past. And I say start with their solution, assume that they put some thought into this, and then iterate on that.
In the context of a meritocracy, appeal to authority is not necessarily a bad thing. Well, so I have two things to say about this. One, because I need to sweep up something that I forgot about in my talk. When you're making decisions with weak evidence or poor data or just too complex a situation to really be amenable to analysis, you do have to reason in the context where you are, but you also need to be doubly skeptical of your own reasoning. And so I forgot to put on the reading list in my talk the book Predictably Irrational by Dan Ariely, or whatever his name is, that talks about the biases in our mind towards irrational behavior and where those come from. The second thing I wanted to say is, if you have experience as a software developer, sometimes your hunches are really good and you should trust them. One time, years ago, I was on a panel at a Java conference, and there was a whole bunch of guys, and Jason Hunter was one of them, and he's the guy who wrote the O'Reilly servlets book, which almost every Java programmer had on their desk for a long time. And somebody in the audience went to the microphone and said, this question is specifically for Jason. He said, you got into, learned about servlets and started using them and became an expert on them when they first came out. And then these EJB things came out, and all of us got distracted and ran over there, and you didn't. You just stuck with servlets, and you've continued to develop that way and never went near EJBs. How did you know? And basically saying, how did you know not to get sidetracked down this rat hole that turned out to be so terrible? And Jason said, well, I had the servlet spec printed out and sitting on my desk, and it was about that thick. And then, the EJB spec came out, and I never printed it, but I could tell from looking at the PDF file that it would be about that thick. And I kind of went, I don't want to learn this. And the guy got mad. It's like, that's not a real answer. But, hunches about complexity bad, simplicity good, sometimes that's wrong, but if it's all you got, it's all you got, and you should trust your hunch.
I want to riff off your first answer.
Okay.
Because it's established that you cannot, by nature, you can't be aware of your own biases in decision making. So one of the only ways that I've seen documented that you can get over your own biases is to have a process of running a decision-making process by other people who don't have the same biases. And then they can help you identify the biases that you have. And that's one of the reasons I'm still a big fan of pair programming.
Mm-hmm.
Because it means you always have someone at your disposal who is passively questioning, your biases and your decision process. I totally agree with you that a lot of problems are solved problems. But I would add, to kind of steer it back to the scientific process, is one disciplined way. Like if you have a problem you need to fix right now, replicate the problem in some automated way. So, write a spec or a test or something that causes the problem to occur, and then fix it in a way that it's provable that you fixed it. And that's, you're writing an experiment that proves that you fixed the problem, instead of just patching it or throwing a Band-Aid on it. And maintaining that discipline is actually one of the best ways that I've experienced personally in terms of running a fairly loose process, as far as not testing everything, kind of throwing a lot of stuff at the wall, and then every once in a while you're going to have regression. Go back, put some test coverage in to cover the regression, and you're good to go.
So I was going to add to what Glenn said about our instincts, and I think it's in Pragmatic Thinking and Learning, which is a great Andy Hunt book, if you haven't read it, about how we think and how our brain works. And he talks about how that's what separates the experts from everybody else, is they have their instincts, which is a blessing and a curse, right? It's when your instincts are right, they're really right, and they let you skip a lot of steps. But sometimes they're wrong, and they're really wrong, right? And they can get you stuck. And so he says that the best thing to do is to listen to your instincts. So when you run into a problem, you have that instinct of, oh, that's over here. But then immediately verify the instinct. Like, measure that it really is over there. If it's over there, you should be able to prove it's over there, know.
Actually, I've told this to a couple of people that I've worked with recently, right along the lines of what you're saying, but just so basic and obvious that it's almost stupid, right? A lot of times something goes wrong, you get an exception, something blows up, and you have an instinct of what it was, and you don't read the exception.
Yes.
I actually mentioned that in my talk this morning.
And you jump into the code to go fix it. And it's like, wait, read the exception, because it's, And that's actually, I think, one of the things that separates a junior programmer from someone that's not junior is forcing yourself to always read the exception.
I have noticed that so many times, and I, years ago said, no, I'm going to force myself to always read the exception. Mm-hmm. But it still bites me when I'm trying to fix something and I make a change that I think will fix it, and it still fails, and I don't verify that it's still the same
exception.
Right.
Yes.
Yeah, we need some sort of output filter that notices that it's a new exception, like highlights it.
Yeah.
Or says same, different.
Yeah, it should say, by the way, you fixed that problem, and now you have another one. Something like that.
Or maybe not. Maybe you just introduced a different problem that hides the previous.
Right.
For some reason, it's a little bit on a tangent, but this conversation just reminds me a little bit of Michael Feather's book, the Legacy Code book. And I think it was in that book that I read about the discipline of when you're trying to understand legacy code and modify it, you start by littering it with assertions. You just, as you read down through it, you start inserting assertions that say something about your assumptions about what the code is doing at that point. And what you're doing is you're just putting in all these little experiments, all these little hypotheses throughout the code, and then you run the code and you see which ones are proved and which ones are disproved.
Right.
Yeah, I've used the anecdote a bunch of times about how I tend to look at code when I'm code reading and I think, oh, this is so easy. I could rewrite this in 10 lines. And I do it, and then I gain a great appreciation for what that code is really doing. You know? That it's much more complicated than it looked to me at first glance or something. I'm sure we could keep talking, but I want to give the audience an opportunity to ask some questions. We really do have a live audience here. Go ahead and make some noise, audience, so they know you're here. They're here.
Sounds like they like us.
Or they're very hungry.
Or they were just told to make some noise.
Right. So let's give them a chance to ask questions, and we'll repeat the question for the purpose of the podcast. Yeah.
So you guys were talking about historical scientific studies. You mentioned some, Glenn, in your talk. You mentioned the law of Demeter. And I know like there's Brooks and Parnas have a lot. What do you say to go that people actually need to go back and go revisit to make sure that they know and learn from some of the things that we're still trying to solve because we haven't actually studied it?
That's a great question. So the question was that we've mentioned several studies or reference many things that we know about that are already solved problems that programmers continue to struggle with. And how is a person to know what resources to go back to study those sources? After you got an answer for that one? I suspect it's
I'm gonna go back to what I said earlier, which is read Code Complete, because that's kind of the starting point. I mean, that'll give you a bunch of good references for some of the sort of older research. You know, an odd source that's actually pretty good is Microsoft. Microsoft is a big enough organization that they actually have a sub-organization that's dedicated to basically just sort of sticking needles and dials into various processes and going like, okay, this team is using TDD and this team is not using TDD, and now we're going to see how productive they are in reference to each other. And so they've actually issued a number of papers where they talk about the results of studies like that.
And the cliff notes of those are Joel Spasky's blog, I think, right? It's something like that, which I don't agree with everything on.
Well, he's a little bit, I mean, he kind of moved out of their,
right, he did leave
their
it.
organization a
But
long
he
time
was in
ago,
there in
so.
one of their super interesting periods, I think,
Yes.
during that.
Some of the pop science books that appear on the bestseller list are actually good places to start. So, like for instance, Drive by Dan Pink was really instrumental to me understanding intrinsic versus extrinsic motivation, and that's something that comes into play in terms of motivating your team and the folks that you're working with, and even motivating yourself. And I could say the same thing for probably 20 other books that have appeared on the bestseller list as far as business bestsellers. The great thing is that most of those books usually have citations to studies that have been done. So if you want to do a deep dive into it, then you just go to your local university or get someone that has access to journals, and you can actually get the white papers. A lot of times you can find them online. And sometimes you even get lucky and find a well of material that you want to build a business on. That's essentially what happened to me with Do Props, is that I started researching an area for my business and got into some of the science for it and decided, hey, this is actually appealing to do as a startup. So.
There's a researcher named Laurie Williams who fairly early on in the days of Agile started trying to find ways to do real studies of programmer behavior and whether what the costs and benefits of pair programming and TDD and things like that were. And I know she's worked with some of the Microsoft guys, and they've collaborated on papers. And as Obie said, the way all this works is you find one paper that is about the topic you're interested in, even tangentially, and then look at the bibliography and go from there. I remember one time in college I had to get I was trying to research something I couldn't find anything on it, and finally found this one paper, and our library didn't have it. I had to send off to have it copied and sent. So I went to go pick up the photocopy. You can tell how old I am now. I went to go pick up the photocopy that had been sent from another library, and it included a note that said, I left out the last page because it was just the bibliography. That was what I really wanted.
I think I'm going to pretty much agree with everybody else's answers, except that I'm just going to add that I learned at least as much reading non-programmer material as I do reading programmer material. Like Glenn mentioned the book Predictably Irrational. Predictably Irrational is a very famous book in skepticism circles. It's a great book about how our brain doesn't work like we expect it to sometimes.
He's got a sequel to it also,
Yes,
by
he
the way.
does.
Right.
It's good also.
And those books especially, I will be reading through them and they'll mention, like the such and such experiments. And I'm like, ooh, that sounds interesting. And I'll Google that and it leads me someplace new. And I think I learn at least as much useful information that I end up applying to my programming that way.
Yeah, I would say some of those are even more valuable because, like for instance, the Laurie Williams studies.
I think that's her name.
I mean, those were super controversial because of the teams she was working with,
Oh,
her
sure.
students, and all this stuff. And
Well,
like when it comes down to it, you don't.
so that's a good point too. I mentioned in my talk today about just how hard it is to reliably do control studies in software, especially when teams are involved. So I would say certainly put more faith in smaller scale, not smaller scale studies, but studies about smaller scale things, right? So the example that Obie mentioned in particular from Code Complete about the correlation between number of code paths through a piece of code and the number of bugs, that's really strong, and it's kind of a small constrained problem, and it's easy to, as a skeptic, think about how you would design a study to determine this, and I think that's probably a really reliable finding. Some of the studies that go back to the 70s about the reduction in bugs just from having code inspections, right? Today we would implement that in a different way, usually with just peer review or pair programming or something like that. But it's a really reliable finding that having more than one pair of eyes on a piece of code really drastically reduces the number of bugs. Those things I think are probably really reliable. Once you get up into the kinds of things that like Lori Williams was doing with measuring different teams against each other and things like that, you can think of all kinds of different variables that might be in there to mess that up. So be a little less trustful of those things unless they're just, really a huge swing.
I think we have a microphone now, so we'll pass it around.
Hello. Hi. I was wondering if you can talk about the relationship that people have towards science versus relationship they have towards craftsmanship. And the conversations I hear on blogs and posts over the last year is there's a certain, like people are enamored with craftsmanship, and there's this mythological thinking about it. Maybe that's my bias towards it, but so it's not science versus craftsmanship, but maybe science and craftsmanship, or the foundation of science being craftsmanship. Can you speak about that a little bit?
I think craftsmanship has a lot of potential pitfalls as something that we're going to use as a metaphor. And those pitfalls being that you can have software that's crafted really well in terms of software quality, in terms of extensibility and various non-functional requirements that make that code beautiful and elegant and well crafted, that don't really speak towards the usefulness of that code for some business purpose. So especially if you apply craftsmanship in business scenarios versus like open source or more artistically oriented scenarios, it's really dangerous. You could the people practicing craftsmanship could end up with a black eye for having put too much emphasis on doing things in an elegant, well-crafted kind of way, and their project fails because it didn't actually meet the needs of the business.
I was going to jump in and say that craftsmanship makes me think of what I'm building, the software that I'm constructing. And to me, the software is just a means to an end. It's the knowledge that I gain when I construct a piece of software that's important to me, right? And some people even talk about how, I believe Zed in that same Peep Code video I mentioned before, talks about how he'll get down a certain line, realize that he's fixing the wrong thing, and though most of us freak out when they see this, he does like a reset at that point at his version control and completely throws away his work. And he says, that doesn't matter. It's what it taught me that matters, right? And I feel that way about what we do, because no matter how invested I am in crafting this application I'm working on right now, that won't be what I'm working on in the future. And I still need to improve my mind and my skills on that. So I'm in it for what I can learn and my best understandings that I have at any given time, as opposed to, obviously I want my software to be good, but my focus is on my gained knowledge more than the thing I'm building, I think.
The ideals of software craftsmanship really resonate with me. I do understand some of those dangers, and certainly, like nearly all the terms we use to describe our field, the word craftsmanship can be easily misunderstood. If you're calling yourself a craftsman and you're not focused on building what your customers need, you've got a reset to do. That's inherently what you want to be thinking about. To me, the importance of software craftsmanship as a movement, or whatever you want to call it, is actually to establish an emphasis that counters one of our biases, one of our cognitive biases, which is that the kinds of bad internal quality in software that craftsmanship is concerned with, this is oversimplified to some degree, but poor factoring, poor design, poor testing practices, those deficiencies in software that craftsmanship worries about are deficiencies that are not obvious, certainly not from the outside, and have a real cost that's off in the future somewhere. And so things that are not obvious and tangible and are not now, but are in the future, we have a tendency to just not think about. And to me, the way I think of the craftsmanship movement is don't recognize the value of good design and good testing and clean factoring of your code. And even though the costs of not doing that are deferred, they're very real. And you need to factor that into your decision making. Now, in some circumstances, it's like, okay, that's a cost we're willing to pay if it comes to that to get something right this instant. But I think an emphasis on those things and keeping them in focus is a really good thing.
Would you agree it's an orthogonal issue to taking an empirical approach to how you decide what to build and how to build it?
Yeah.
Yeah,
Yeah.
I mean,
Sure.
The idea is like how they met.
Well-
I see people going.
Well, I think they're two different concerns, you know, from what we're talking about. You can take a scientific approach to deciding what you're going to build and how you're going to structure the team that's going to build it, and the assumptions, you know, and how you document the assumptions in the experiments, and still write really poorly crafted software or not, you know.
I'd like to use an example from the world outside software, and it's a world we're still all familiar with, and that is Apple industrial design. Okay, so for a long time, it hasn't happened in a while, but for a long time at Apple keynote events and things, Steve Jobs would have Johnny Ive take the stage and talk about their industrial design process and the things we were doing, or things they were doing. And he would get up there and talk about materials and the beautiful simplicity of glass and the characteristics of aluminum and
Steve
you know.
told me to make a sunflower.
Exactly. And you know, I'm sure that 99% of their competitors and a pretty significant percentage of their customers were going, oh, give me a break. But that level of craftsmanship has had real positive consequences for them. It turns out that because they started, you know, really trying to work with the best materials they could, well, it turns out that aluminum has some characteristics that make it really good for machine milling with very little waste of materials, and that allowed them to build unibody machines that are light and rigid and all this kind of stuff, and you've probably heard this, so I don't need to go on. But I doubt very seriously they were thinking about that characteristic of aluminum when they started down that path. And this has had a profound effect on their business. And now lo and behold, their competitors can't match them on price, even though they have the largest margins in the industry. And I think a lot of that was a sort of beneficial side effect of a focus on craftsmanship. Note, at every step of the way, they were clearly concerned with building a business and being profitable and meeting customers' needs, and it didn't stop them from building machines that now they'd probably look back on and say, wow, those are crappy, right? But that was the best they knew how to do at the time, and while they were figuring out how to do it better, they still built what they knew how to build right then. So craftsmanship has real benefits long-term. It shouldn't be allowed to get in the way of meeting the needs right now, and I don't think there's any real conflict there.
There's a caveat to that, which
Okay.
is that a lot of teams can't afford to have a master craftsman, or just because of the realities of the labor market, don't have one available that actually knows what good craftsmanship is. And that's where a lot of that kind of falls apart until we get to the point where there's more.
Yeah, I think that's
crafting.
right, but I think the point is that this should be something that we teach and is a part
for
of how
sure.
we bring up young programmers to value those things, not to value them inordinately, but to see the value of good design and those kinds of things.
When I think of craftsmanship, I think a lot of people when they look at craftsmanship, especially in the context of software, I think they imagine somebody sort of poring over a piece of work very carefully, you know, and very, you know, taking little chips at it and you know, being very meticulous and taking a long time about it. When I think of craftsmanship, I think of my grandfather, who was many things. He was an engineer. He was a lot of different things, but one of the things he was a master woodworker. And you know, and watching him, he wasn't, you know, he made beautiful things, but he wasn't, you know, meticulously, slowly chipping away at them. What he did was he made swift, sure cuts.
Yeah.
He had practiced so much that he had the right instincts. You know, he measured, certainly, you know, he measured carefully, and then he cut quickly, and he made the right cut, and he didn't have to do it again. And so I think, you know, I think that there's an idea that craftsmanship is always equivalent to going more slowly. And I think that if that is your idea of craftsmanship, you're selling yourself short. You're selling your abilities short. I think craftsmanship to me is about, I think where it meets science for me, it's about internalizing the lessons that you've learned to the point that they're intuitive. To the point that you could, if you thought about it long enough, realize the chain of deductions you made intuitively to come to the decision that you made, but you made it so fast that it was an intuitive deduction, and you decided how to move forward with this design, and you did it in a split second.
Right.
And that to me is craftsmanship. It's not a slow process. It's a process of internalizing things until they are fast.
I think I pretty much agree with Avdi about how that goes. And the only other thing I wanted to add is that in both systems, you're talking about people that are measuring what they're doing, observing the effects of that, and trying to improve their skill. No matter what your system is for that, you've already won. You're doing the right thing.
Yeah.
You know, if you're checking your process, if you're trying to improve it, if you're making it better, that's what's important, in my opinion. Next question.
There?
Yeah.
So I think you guys are spot on, and something really tickled my mind when you guys were talking earlier, which is that we are biased as programmers to think of metrics that we care about, like lines of code and test coverage and crap like that our customers don't find value in. And I think it was Obie that said it, that we can't measure features, or was it Glenn? I don't remember.
I said we can't measure features, and Obie reminded me that that's not what we care about measuring in the first place.
Exactly. So my real question that I think that we should apply some science to is, what should we measure, and what is it that adds value that we can really do something about, that we should be focused on, instead of the kind of mental masturbation that is all the software development stuff that we focus on, right? I mean, I'm not trying to denigrate any of that because I really love test-driven development and all that, but it's self-serving. It makes me feel happy.
Well, I mean, most of the software that any of us are getting paid to write is meant to facilitate something else in the non-software world, or in some other software system. So the answer to your question is kind of necessarily has to do with what that software is intended to do. So for any given function of the software, you look at what it's supposed to do, you see what doing that better would entail, and then you derive a function from it, whether it's some mean that's changing, or some level or something like that. It's one of the reasons I really like the tool Kissmetrics is because it gives you a framework for firing events off from your software to a repository, and then gives you a web-based interface that gives you some wizards and forms for deriving metrics. Because unless you've studied the process of creating metrics and stuff like that, you don't really know where to start. And that's why I'm saying that more tools like that are necessary.
Kathy Sierra, and I think I'm going to get this quote wrong, but Kathy Sierra likes to say, don't worry about making yourself awesome. Worry about helping your customers be awesome at what they want to do. And that kind
That's
of
good
metric,
advice overall. For
right?
Sure.
That kind of metric. If you can find metrics that measure how awesome your customers can be using your system or whatever, and improve those, and then measure how rapidly you improve those and improve that.
And you can tie them to money.
Yeah.
It's even
You're in good
better.
shape.
I agree with what they've been saying. The only thing I thought of adding is that in the beginning, when I don't know, I cast a wider net and try to look at more things. And then as I'm zeroing in on what is the most important to me, I try to restrict that back down into the things. Sometimes it's easier for me to see from the 10,000-foot view first and then work my way into what really matters, the 3 points that seem to matter the most.
There's the concept of a minimum viable product gets thrown around a lot, or MVP. So when you're starting a new project, you're in a rush to get to your MVP so that you can release. And one of the best ways lately that I've heard MVP described is the earliest stage at which you can test assumptions, which clarifies things for me quite a bit. Because otherwise, if you don't have that kind of clarification, you're like, well, what constitutes viable? Viable to what? Viable for them to do something. Okay, well, how do I test to do something? And then it all kinds of becomes clear there.
I think it's surprising, too, how far you can take that. Like, I'm working on launching a product of my own at the moment, and I'm really trying to do that. Say, what is the core chunk of this? And you can't believe how many things you can throw out when you do that, you know? I mean, you look at it, it'll be great to have comments here. Comments is a side thing that we'll get someday, but it doesn't have to do with what I'm trying to do here. Right?
Well, yeah, to riff on that, basically what comments on some, typical web kind of product, what are they meant to do? They're probably meant to increase engagement or visits or something like that, right? So you want to write a test for that. And you have to get the system to the state right before you add the comments, and then start tracking that metric so that you know whether it was worth adding comments or not. Right. Maybe you add comments and that metric goes down.
As the internet response effect happens, yeah. Exactly. I don't want to go too far over. We usually try to keep our shows right at an hour, so how about we'll take one more question. Who's brave?
Microphones, how do they work? It says mute right there. That's not mute at all. I guess it's maybe the opposite. Is this actually working? It should be green. It's green. Oh, there we go. Hey guys. So as a programmer, my brain is always pattern matching, right? So I'm trying to think, okay, what's a situation where this has happened before? And this sounds to me a lot like the reinvention of Taylorism and scientific management. And when that started to be introduced, it changed the way that management worked. And so I can't off the top of my head think a lot about what a lot of criticisms of Taylorism are, but a common thing that I hear about metrics is that you have to make sure that it's not leading you into a local optimization as opposed to a global one. And so I think that metrics are great and that we should follow them, but also not to make sure that we do make larger scale changes when they're actually needed in order to advance a metric even further. It's really easy to get trapped into those kinds of like, you know, if I'm changing the text of my headlines and it's converting a little better, that's great, but maybe the page's design is poor and we could actually advance even more by focusing on changing that as opposed to changing a headline. So it's sort of a question / comment, I guess, if there's an easy way to know when you're making a hyper-local optimization as opposed to like measuring something that's bigger or that would be a larger change, I guess.
So I just wanted to apply a tiny correction. He said that as a programmer, his brain is always pattern matching. What he meant to say is, as a human, his brain is always pattern matching.
Right.
Okay, but other than that, the question was great, yeah.
Let's just use an example from what we were just talking about. Putting comments on a web page, supporting comments on a web page. And you know, Obie said you get the measurement in place and then you launch that feature and you may find that the level of engagement goes down. Or maybe it goes up at first and then it goes down, or you know, who knows? But it turns out to be a net negative. Well, so then how do you draw conclusions from this? The kind of narrow conclusion would be, oh, comments are clearly a bad idea for purpose of engagement on this site. But it might be the way you implemented it, or that unmoderated comments are a net negative because people are turned off by negativity or something there and go away. But if you had moderated comments that raised the level of discourse, that would be a really good thing. There's all kinds of ways you can go from that. You have to interpret the metrics in terms of a model of what you're trying to achieve. And you know, in that particular case, that model would incorporate who your customers are and how they think. You know, I've been talking a lot recently about engineering. And a really good book about engineering is by Fred Brooks. It's his recent book called The Design of Design. And Brooks was educated as an engineer and then found himself in the software world, in the computer world. And when he was in engineering school, in the foreword or preface of that book, he talks about being in engineering school at MIT. And the dean of the engineering school at that time at MIT was this Nobel Prize winning physicist. I can't remember what his name was. And he was very concerned that engineering should be more of a science and should be grounded in the findings of science to a much greater degree than it was. And he led, from his position as Dean of Engineering at MIT, led a big shift in engineering education in this country towards being more of a scientific discipline. And there has been a backlash against that by engineers because of exactly those concerns. It leads to a very narrow kind of thinking and demotes the idea of design. And engineering is fundamentally a design discipline that employs scientific findings rather than a science itself. And so, you know, I think we need to have good models of what we're trying to achieve and try to think beyond narrow metrics and maybe take bold experiments sometimes that might be counterindicated by what we've measured, but you know, might help us break out of a narrow viewpoint.
So the more tools and infrastructure that we have for taking those experiments, the more they'll happen.
Yeah,
one of the reasons that they don't happen now is because the tools and frameworks for doing it don't exist. Quick point to your question. In the kind of grand vision for this experiment or goal-oriented development, the designer / developer, programmer team or whoever's implementing features, I think actually gains a hell of a lot more freedom to be an artist and craftsman and to do the implementation the way that they want to, if the business is trained to look at the experiment's results. You know, we're basically, okay, we're looking to improve retention by 8% by adding commenting go. And literally that would be the requirement that's communicated to the team. And then the team would be comprised of experts that would know how to build a commenting system in maybe 3 different ways: unmoderated, moderated, threaded, non-threaded. And they go and they do it, and they find the one that satisfies the metrics that have been provided in you know, the best form. And it actually, I think it gets rid of business interference in what should be the domain of the programmer designer, in letting them implement stuff the way that they know it needs to be implemented. And why should a product manager, you know, an analyst, someone that is responsible for meeting financial goals of the company, be discussing the proportionality of a particular text field to the another text field? That's bullshit. We have folks that are experts in doing that. Let them do their job without interference, and that it saves a lot of time spent in meetings, it saves a lot of documentation, a lot of grief, and just speeds everything up.
So I think the only thing I really thought to add on those points was that if I'm making little improvements and things are still getting better, then I'm happy. If, you know, as that begins to slow down, which inevitably it will, then I guess that leads me to assume I've gone about as far on that wagon as I can go, you know, and it's time to start looking at different angles and expand my view, my scope, I think is one thing. And another thing is not to be afraid when you admit when you make a mistake, right? That's the thing you see over and over again, right? Was it the Gap logo that turned out to be the huge fiasco? Or
Yeah.
What about the new Skype? I mean, can we call that a mistake yet? It's a mistake, okay? It's
code.
absolutely the worst UI design I've ever seen. I mean, it's a mistake, you know? I feel like we can, at some point, admit that and say, you know what, we didn't do the right thing or whatever. And
Well, so it's nice that they took a bold step in both of those cases. But the
True.
problem was that they weren't ready to acknowledge it as an experiment that they could pull back from.
Right. Yeah, which is like Google's way, right? Think about it. Does Google, I mean, man, they mercilessly kill everything. And we don't even
We spent
care.
$1 billion on this wave thing.
I know. Okay. And they put everything in the quote unquote lab in beta, you know, and everything's like internally in beta. Yeah, or labs is gone now. Yeah, right. And then they just, you know, they try something for a while, and if it catches on, it's awesome, and that's great, and we'll keep that. And if it doesn't, they just kill it, and it doesn't matter because it was beta anyway. You know, it's nothing. Everything at Google is an experiment, right? Ready to fail, like, you know.
Yeah. Has easy flags, or has easy is one of my favorite Rails plugins now for a while. It basically lets you add arbitrary, you know, tuples to a class. Which means you can very easily add flags or preferences to, say, a user class, which means it's very easy to give the user the option to turn on things that you're not sure about.
Right.
You know, how they're going to work. Instead of rolling them out to everybody, you just sneak a checkbox onto their settings screen, and you know that some percentage of them are going to click on it and turn it on, and then you just see what happens for those that do. So, thought I'd throw that in there.
It's a good idea. All right, so I guess we'll wrap it up here. I want to go around the panelists one more time and thank them. And they may want to make little announcements. So like Avdi, thank you for joining us again. And where can people see you at Lone Star tomorrow?
Wait, what?
At Lone Star tomorrow. Are you doing anything at Lone Star tomorrow? Thought I saw you working on a lightning talk.
Oh, yeah. This has been fun, and I think I will be doing a lightning talk tomorrow if I can get it on the schedule. Again, more stuff about me, obd.org. Happy hacking.
Glenn?
Yeah, it's been fun. I'm at Vanderburg.org. He chose his first name. Couldn't get Glenn.org. So, I'll be at SCNA later this year. That's about it.
Obie, thanks for joining us.
Thank you for having me. ObieFernandez.com. I'm actually getting into the lean startup circles with Eric Rees and some of the other folks in that community, and mentoring a series of workshop conferences called Lean Startup Machine. So the next two that we have are coming up in September in London, Edinburgh, and Berlin. So Lean Startup Machine, Google it, or check my blog, and just talk about the intersection of Agile and Lean and all that stuff. I see a lot of potential for innovation there.
And I've been your host, James Overgray II, and we'll see you next week.